All right, today we're going to look at a concept that involves the role that zero plays in different situations, and then we're going to look at three specific ones, and we're going to use a fact that we know as a basis. And you've seen me do this before. We would all agree that 10 divided by 2 is 5, and therefore 5 times 2 is 10. What if we have 0 divided by 10 equals question mark? That means that question mark times 10 must equal 0. Well, what could the question mark be? Well, it must be 0. And so we call that a 0. And on a graph, that leads to x-intercepts, sometimes called the roots of the function. If we look at the next situation, 10 divided by 0 equals question mark. Well, that means the question mark times 0 equals 10. Does anyone know a number that when you multiply it by 0, you get 10? And the answer is no. There's no number that will work. So we call that undefined. It doesn't exist, can't answer that question. And the last situation is, what if we have 0 over 0? And then the question becomes, what number times 0 is 0? Well, every number times 0 is 0. It's impossible to answer, not because it doesn't exist, but because we can't specifically determine that value. And that word that we use is indeterminate to describe that. And this whole assignment is, how do we know if the answer is going to be 0, undefined, or indeterminate? So let's look at an example. It will be helpful for us to always factor first, so you'll notice that as I look at this question, I'm automatically going to factor the numerator and the denominator. I can't do the denominator, it's a sum. And so the question is, where is this going to equal 0, which means that we only get 0 on the top? Where is it undefined, which means we only get 0 on the bottom? And where is it indeterminate, which would get you 0 in both the numerator and the denominator? And we usually start, or at least I always start with C, with the indeterminate. Is there any value of x that will make both the bottom and top 0? And I would say there is no value that will make both the top and the bottom 0. Well, what value would make just the bottom 0? Well, no matter what number we pick, unless we go into the imaginary numbers, which we don't in this class, there's no number that will, when we square it, will get us a 0 on the bottom. So there's none that will make it equal or undefined. And the last situation, what will make the top 0? Well, that will be if x is equal to plus or minus 2. That will make the top 0, and that will make it x-intercepts, or the roots being 2 or negative 2. Let's take a look at a different one. If we factor the numerator, we end up with that. So again, A, B, C. I always start with C, indeterminate. Is there a value of x that will make both the top and the bottom 0? And if we look at this factor, yes, there is an answer. It's 2. So if x is 2, the answer will be 0 over 0, which we say there's no solution to that. So you'll notice on the graph over here that at 2, we end up with something called a hole, which means that although the graph appears to be a straight line, there's a gap there at 2, because they always cancel out. No matter what x value there is, those two terms, or those two factors, will cancel out every time, and you're just left with x plus 1. All right, let's fill these other two in. What value will make only the bottom 0 but not the top? None. 2 does make the bottom 0, but also the top, so it goes in the indeterminate category. And then what will make the top 0 is minus 1, which corresponds to right there in the graph. That's where it crosses the x-axis. Sorry, that circle's a little off. It should be more like right there. And let's go to the next question. Gets to be a little bit more complicated, but the process is the same. Factor first. Actually, that's a difference of squares, so I might as well do that all at once. On the bottom, I'm going to take an x out and then factor that hopefully correctly. So again, A, B, C. 0, undefined, indeterminate. I start with indeterminate. What factors make the top and the bottom 0? Oh, 0 is one answer. We also have a factor that's shared there, so positive 3 would also make the top and bottom 0. Then we have a factor that is only on the bottom, so that would make the bottom 0, which is undefined. And then lastly, we have the numerator, x plus 3, so that would make the top 0 but not the bottom. And so the 0 is minus 3. Let's look at question 4, where everything is factored And we have to determine if there's a value that would make both the top and the bottom 0. So when I look, for instance, at these two, although the factors aren't the same, the zeros for both would be 2 squared minus 4 is 0, as is 2 minus 2. So definitely indeterminate at 2. Let's take a look at the logarithm. To solve that logarithm, I'm just going to write down here. Right now, we are looking for where it equals 0. So if I rearrange that logarithm into exponent form, we would get that. And now if I solve for x, I'm going to get x squared equals 0, so x equals 0. Is there a factor that makes this logarithm 0 and the top 0? No, only 0 makes that 0. That won't affect the top, so that will be undefined if x is 0. And then on the top, we get x equals 4. You might have some questions about that logarithm. Make sure you ask about them. And then the last one, again, if we factor first, x squared out, x squared plus 4. The bottom is 3 to the power x. And a, b, c. What would make the bottom 0? Is there any power that will make 3 0? 3 to the 0 would be 1. 3 to a negative just means it's a fraction, so there's no way the bottom is going to be 0. So the answers for undefined and indeterminate are none. There are no values that will make it 0. And then for the numerator, x could be 0, but that's it. X squared plus 4 will never be negative or 0, because no matter what, you're always going to end up with the lowest value of being 4. Now, along with indeterminate, undefined, and your zeros come 3 situations. You get a hole, which is indeterminate. You get a vertical asymptote, which is your undefined. Sometimes we end up abbreviating indeterminate to indeter. And then vertical asymptote is with your undefined. And if it's not one of those two, it's neither, which often leads to an x-intercept. So let's look at question A. There is no numerator with x, therefore there are neither asymptotes nor holes. If we look at B, x minus 1 is a undefined situation because it makes the bottom 0 but not the top. So we'd say there's a vertical asymptote at x equals 1. Question C, 1 would make the bottom 0 again, but also the top. This time we would say it's indeterminate, so there would now be a hole when x equals 1. And you would find the value of that hole by putting 1 into your expression. So what happens is when I consider this, we get 0 times 0 over 0. These would cancel out, and you still would get 0, so the hole would occur at 1 and 0. For the question D, where would the denominator and the numerator be 0? Well, you would say there's a hole at x equaling 1, but once you cancel those out, you still have an x minus 1 on the bottom, which leads to a vertical asymptote at x equaling 1. And basically what happens is, if there's an asymptote, there can't be a hole, so the asymptote wins out, so to speak. It always takes precedence when we talk about graphing. So that's it. If you could fill in your form, please, and bring any questions that you have to class next time.